What's this? Wow!
Bunny burrito.
Hello, Dr. Payam.
Hello, and welcome to the exciting continuation of variation of parameters. So last time I showed you this nice formula that works for single equations. It turns out you can use the same method to solve systems of differential equations. Whoa! And again, witness the power of linear algebra. It's a very cool subject. So, let's use variation of parameters to solve the system x prime equals to ax plus f, where A is the matrix 2, 1, 0, 4, and f is the inhomogeneous term e to the x and e to the 3x. Now again, it's the same thing as before. You first find a homogeneous solution. Let's call it x naught of x. It's just, well, I won't do it here, but there's some other video floating around of me that does it. The way you do it, you find the eigenvalues. So here it's not bad, it's 2 and 4 because it's upper triangular, and you find the eigenvectors. Well, if you do that, you get a e to the 2x times 1, 0 plus b e to the 4x times 1, 2. Sorry for using a twice, but here we have constants a and b. But don't worry, they will disappear. And you can write this as a e to the 2x, 0, plus b e to the 4x, 2e to the 4x. Great! Half of our work is done, but that was the easy half. Now let's find a particular solution. Again, just as before, we had constants and maybe functions. Variation of parameters, what does it say? Let's guess that our solution has the same form, except instead of constants, we have functions. So, we guess that the particular solution is of the form v1 of x times the first vector plus v2 of x times the second vector. E of 4x, 2e 4x. And guess what? The variation of parameters formula, it's almost exactly the same. Namely, what do we have? Before, what we did, we had the Wronskian, which meant we have two functions, we differentiate the hell out of them. It turns out we don't need to do that anymore, because instead of functions, we have vectors. So literally, put the two vectors you found inside a matrix to get this matrix. And then v1 prime, v2 prime, just as before. And before we put some vector 0 in the inhomogeneous term, but lo and behold, we already have our inhomogeneous term, that's our vector. So we put this, e to the x, e to the 3x. And I do realize you could use undetermined coefficients for that, but this is more systematic and works for any kind of inhomogeneous equation. But look, what do we have then? This is an equation for v1 prime and v2 prime. Therefore, v1 prime, v2 prime is the inverse of this. So e to the 4x, 0, 2e to the 4x, inverse of e to the x, e to the 3x. Okay, let's find the inverse. Remember, it's 1 over the determinant. The determinant is e to the 2x times 2e to the 4x, which becomes 1 over 2 e to the 6x. And then you just interchange those two. So 2e to the 4x and e to the 2x. And for the other things, you just put a minus sign. So minus e to the 4x and the minus 0, which is 0. All this applied to the vector e to the x, e to the 3x. Great. multiply this vector and you then divide by 1 over 2e to the 6x. So 1 over 2e to the 6x times 2e to the 5x minus e to the 7x. 7x, and then 0 times e to the x plus e to the 5x, which just becomes e to the 5x. And then remember, you divide this by 1/2 e to the 6x. So in other words, what you get in the end is v1 prime, v2 prime is e to the minus x minus 1/2 e to the x and 1/2 e to the minus x. And now it's integration time. Woo! So, in other words, what we get, is that v1 becomes integral of this, e to the minus x minus 1/2 e to the x dx, which is minus e to the minus x minus 1/2 e to the x, and v2 is integral of 1/2 e to the minus x dx, and that's minus 1/2 e to the minus x. And again, we don't need any constants because it turns out they'll just get swallowed in the homogeneous solution. So, in the end, what do we have? We have our particular solution. It's again v1 times our first homogeneous solution plus v2 times our second homogeneous solution, which becomes minus e to the minus x minus 1/2 e to the x times e to the 2x0 plus minus 1/2 e to the minus x e to the 4x 2e to the 4x. It's a e to the x party. Okay. And then if you calculate this, you get minus e to the minus x plus 2x is x minus 1/2 e to the 3x minus 1/2. Look at that, another e to the 3x. And then this becomes 0 plus, minus e to the 3x, which if you want, you can simplify it as minus e to the x minus e to the 3x, and then minus e to the 3x. And last but not least, you get your general solution, x of x equals to x naught of x, lots of x's here, plus xp of x, which becomes a times e to the 2x0 plus b times e to the 4x 2e to the 4x plus, well, I guess maybe let's put minus or something, e to the x plus e to the 3x e to the 3x. And then we're done, and we can go home very happy. It's a matrix box if you want. Thank you so much for surviving the first week of the course, So let's just continue our adventure afterwards with integration techniques. Thank you very much, and have a